For our review of common factoring, we're going to look at both terms, the 3x and the -9, and we're going to ask ourselves what factors are common to both of them. So both terms are divisible by 3, so we're going to take the number that we factor out and put it outside of the brackets. And then we're going to look at the first term. 3 divided by 3 equals 1, and there's 1x still there because we didn't factor out any variables in this. -9 divided by 3 is -3. Oops, it's -3. So that's our answer there when we common factor. We could check our work if we wanted. Let's just do a little check down below by doing distributive property. So I'm going to write my solution here. And if I do the distributive property to it, the outside term multiplied by the two inside terms, we should get ourselves back to the original question if we did it properly. So 3 times 1x is 3x, and 3 times -3 is -9. So therefore we did the question properly. Now let's look at this question here. For both terms, we could divide them both by 5, but we need to realize that we could also divide them both by 25, and we always want to factor out the greatest common factor to both. So here we're going to factor out 25, open our brackets. 25 divided by 25 is 1, and we have our x there. -100 divided by 25 is -4. So that would be our final answer. Again, you could do a quick check using distributive property to see whether you've done it correctly. In this question here, we're going to also look at factoring out variables now. So we can see that we have an x in the first term and an x in the second term. So when that occurs, then not only are we looking to factor out, sorry, let's get back to the pen here. Not only are we looking to factor out the constant, the number in front, we also want to factor out the variable. So in both terms, 4 is the greatest common factor. You could use 2, but that wouldn't factor the equation fully. Next, we need to ask ourselves, how many x's can we take from both terms? The most we can take from the first term is 5, so that's what we have common to both. We have 5 x's common in the first and second term. So, same process, 4 divided by 4 equals 1. We don't really need to show that 1, but early on we will. There was 5 x's. We factor out 5 of them so there aren't any more in the first term. -12 divided by 4 is -3. There was 7 x's in the second term. We factored out 5 of them. Now we only have 2. We'll show this again really quickly, how you can check your work. So if we write our solution down here, and then do distributive property to it, we should get back to our original question. So 4 times 1 is 4 with our 5 x's. 4 times -3 is 12, and 5 x's plus 2 more is 7. So we can check before we even hand in our work that we've done it correctly. Our last common factor example here, we have to look to see what's common with all terms, and 3 goes into all those terms evenly, or those 3 terms are all divisible by 3 evenly. There's not 1x common in all of them. See, this third term doesn't have any x's, so we cannot factor out x. But there are 2 y's, no, there's no y's common either. So at this point, the only thing we can do is factor out our 3. So 15 divided by 3 equals 5, and then we're still left with our x, 1, y squared. -12 divided by 3 is -4, leaving us with 4 x's. -21 divided by 3 is -7. So it's really important to realize here and see the reason that we didn't factor out any variables is because there wasn't any x's in all 3 terms. We only had it in the first 2 terms, so we couldn't factor out any x's. And you can see we only had y's in the first and third term, not in the middle term, so we couldn't factor out y as well.